Okay, so what I want to talk to you today, the notes that you wrote down in class, dealing with solving systems of linear equations by the elimination method. So that's, oops, me and my silly colors, huh? So our objective is to understand, oops, how to solve a system of equations. I'm going to say linear, because we are going to talk about system of inequalities as well. Using elimination. So if you think about the word elimination, to eliminate means to get rid of. So what we're going to do is somehow these equations are going to be set up so that when I do some math, it's going to get rid of one of the variables or eliminate it. So again, we talked yesterday about when do I use substitution. I use it when I have one of the equations that has one variable without a coefficient, preferably already isolated and solved for that variable. So let me talk a little bit about when do I use this method. So when to use elimination. Oh, and I wrote eliminate over here, sorry. Elimination. So we have two case scenarios when I like to use this. First would be I have two variables that match exactly. Now, when I'm talking about two variables, I'm saying a variable from each of the two equations. So two of these variables from the two equations that match exactly. And when I mean exactly, I mean this. Same variable, same coefficient, so that's the number in front of the variable. And third thing, same sign. So that's case one, what I'm looking for before I would use this strategy, this technique. Next one, and this is actually the better one to be honest with you, are two variables that they match closely. And I'm not going to write match closely, but that's really what we're looking for. But they match with same coefficient, or I should say, you know what, let's do it this way. Yeah. We'll say match closely. We'll go ahead and go that route, and then I'll dole out what closely should look like. So that's going to be the same variable, so both x's or both y's. Same coefficient, so same number in front of each of them. And not same sign, because we already had that, we would have opposite signs. And honestly, this is actually the better one, because if I have this, my elimination process is going to go super easily. Now, yesterday we went through an example first, and then we wrote down the process. You've already had the opportunity to look at this set of notes, so I'm going to go ahead and go through the process, and then I only have two examples for you, so I'm going to save those both to the end. So let's talk about what's the process for elimination. So what am I going to do to eliminate or get rid of something? Okay, so process. Let's start with step one. What you're going to do is, in order to eliminate, we need to combine the two equations in such a way that the variable that matches with the same coefficient is going to eliminate. Okay? So That's our goal, is we're going to eliminate one variable and then there's two options. Option one, if the signs are opposites, all I need to do is add the two equations together. So we can eliminate one variable by adding, or if my variables have the same coefficient with the same sign, now I'm going to have to subtract them. So adding or subtracting. And we don't just subtract them, we have to subtract the two equations all together. So eliminate one variable by adding or subtracting the two equations. So what I've just done is eliminated a variable, and I have one variable left, and that's what I'm going to solve for. So step 2 would be solve for the remaining variable. Okay, so now we got an answer, and now, but we only have half of the answer. So that's half of my solution, half of my ordered pair. We're going to go back, and remember I told you this yesterday, we're going to be using substitution in every one of our ideas or every one of our techniques except for the graphing. And so substitution comes in now because now we're going to take the value we just solved and got, and we're going to substitute it back into either original equation and solve for the other variable. So substitute this value, the one we got in step 2, into, and this is, we talked about this yesterday, either original equation and solve for the other variable. And then last, so we're going to write the answer as an ordered pair. And again, if the variables are not x's and y's, then we're going to follow alpha order, so alphabetical order. Okay, so let's go ahead and do a couple of these problems to practice. Directions are going to say solve. So again, what we're looking for this time is, do we have a set of the same variables that have the same coefficient in either opposite signs or the same sign? That's our best case scenario. Now some of you might say, well, can't I use substitution on these problems? And the answer is yes, except for on tonight, no, because you have to follow the strategy that's given. Now generally what they do, and again this is from a space perspective, but it ends up being a really good idea from a solving perspective, is that we have the two equations are written vertically, which kind of makes the math a lot easier. So what I'm going to do is look for, do I have a variable that has the same coefficient and the same sign? Ooh, look at that, we do. That would be our two x's. Do we have the better case scenario where we have the same variable with the same coefficient but opposite signs? And lo and behold, we have that. Now, if I have the second case scenario, like I do with the y's, there's nothing I need to do to this equation except to add. When I subtract, which I'll show you in the next problem, it's now going to affect a big change that I'm going to have to change signs on an entire equation. So let's go back. Let's erase these guys. And so basically all I do at this point is draw my line, and I'm going to add my equations together. So 2x plus 2x is 4x. X take away x becomes 0. That's the elimination. We eliminated the y's. And then we have 7 plus 3 is 20, 13 is 20. And then we just divide both sides by 4. And we get x is equal to 5. So now that's half of my solution. That's the x value. And now we're going to calculate the y value. So with the y value, we're going to take the value for x and we're going to plug it into either original equation, and it doesn't matter which. So remember, I'm trying to solve for y, so I think the smarter choice would be to pick the equation that has a positive y, because that's going to be one less step I'm going to have to do to solve this problem. So now we get 2 times the quantity 5, substituting in that 5 for the x, and we write out the rest of the equation, plus y equals 7. So that gives me 10 plus y equals 7, subtract 10 from both sides, and we get y equals negative 3. So now it appears negative 3 is going to be the y-coordinate of my problem. So what I'm going to do is check. So is 2 times 5 plus negative 3 equal to 7? So is 10 take away 3 equal to 7? And it is. So what that says is it satisfies the first equation. But it needs to satisfy both. So 2 times 5 minus negative 3, does that equal 13? So I get 10 plus 3 equals 13. And I get 13 equals 13. So that verifies that my solution is 5, negative 3. Okay? All right, so I want to give you the second example, the last one. Excuse me. And in this case, we don't have the best case match. What we have is the identical match. So we have same variable, same coefficient, same sign. And I'm going to show you how you're going to have to alter that problem. Okay, so problem 2. We've got 2a minus 3c equals 20. And we have a minus 3c equals 13. And I can just hear people say, hey, why don't we just solve the second equation for a and then use substitution? Yeah, that would be a great idea. However, we have to use this elimination method. Now, you might note that the book calls it addition and subtraction method, and that's because that's the operation you use in order to get rid of one of the variables. So what you should notice is that we do have an exact match on the c's. So we have the same variable c with the same coefficient 3 with the same sign negative. So this is, I can't add and get rid of them. I'm going to have to subtract. So here's how I show subtraction. When I subtract, it's like I'm multiplying the entire equation by negative 1. So what that allows me to get is a sign change for every term. Positive becomes negative, negative becomes positive, positive becomes negative. And then I'm ready at this point to add in a way, because remember, subtracting is the same as adding, the opposite. So we have 2a take away a is a. My 3c, negative 3c and a positive 3c cancel each other out and give me 0. And then we have 20 plus negative 13 is 7. So that looks like to be half of my answer. Now again, we're going to go alpha order, and A comes first in the alphabet. C will come next. So now I'm going to take that A, oops, wrong circle, take the A value, and I'm going to plug it back into the original equation. So let me remind you what the original equations were. 2a minus 3c equals 20, and a minus 3c equals 13. So the best place for me to substitute in the 7 would be into the second equation, because the a that I'm trying to solve for is already alone. So let me rewrite that equation. Oops, equals 13. So remember, all the reds are gone. So now I'm going to take that 7 and I'm going to substitute it in for the a, and then I'll be able to solve for c. So I get 7 minus 3c equals 13, and then I subtract 7 from both sides, and I get negative 3c equals 6, and then I'm going to divide both sides by negative 3. and I get C equals -2. So it looks like my answer, oops, that's not a very nice drawing. Let's try that again. Is the order pair 7, -2 is where the two lines really intersect. But again, I'm going to check. And let's see, 2 times 7 minus 3 times -2, does that equal 20? And we get 14, two negatives make a positive, and I get a 6, and I get 20 equals 20. So since it satisfies the top equation, that's great. Let's try the second equation. Oops. A, which is 7, minus 3 times C, which is -2, does that equal 13? So I get 7, two negatives make a positive, 3 times 2 is 6, and 7 plus 6 is 13. So I get 13 equals 13, which is true. So now it satisfied the second equation. So that verifies that 7, -2 is the solution. All right, that's it. Good luck on your homework.